Hey everybody. Welcome to the April meetup of CocoaHeadsNL. I don't know how many meetups we did over the years, but it's a lot. And this is yet another one at a great sponsor, at a great site, Triodos Bank. Thank you for having us today. Before we start, we have a little bit of a program, and I do my usual blurb at the start of a meetup. So what is CocoaHeadsNL? We're a monthly meetup of iOS and usually some Mac developers. We talk about anything Apple related really, and if you want to join us, please look us up on meetup.com/CocoaHeadsNL and just have a look at our next meetups, because we have a lot of them scheduled by now. We've had a bit of a drought in the number of meetups, but we have a nice packed schedule for the next few months on Meetup, so definitely check that out. We have our usual sponsors that you can see on the screen here. I can name them all, but we probably already all know these logos, at least if you're from the Netherlands, because the center one is the Dutch Railways. If you're in the Netherlands, they're always on time, right? Sorry. If you want to get some nice swag, this is the URL that you have to go to, CocoaHeads.nl/shop, and then you can order your swag yourself. You actually sponsor CocoaHeads a little bit as well if you decide to get one of these items. And we actually have a few of these items running wild at the meetup today. So we have the red shirt here, and we have the black shirt in the back. So agenda for today is Jesse. He will do a little bit of an introduction on what iOS development at Triodos Bank is all about, and also probably why it's a great place to actually work. Well, looking at the site that we're at, I think lunch walks are a bit of a thing here, looking at the forested area around the building, which is great. So that's already a perk that you're getting if you actually decide to work for Triodos. And after that, we have two talks. Something about UI testing with network mocking by Tieme. And we actually have Vision Pro devices on site today. So if you see somebody walking around with ski goggles on, it's probably a Vision Pro. So be aware of that. And it's a bit of a live demo for iOS developers, so that we all get maybe a little bit of close-up experience with what Vision is about and what you could actually do with that. So if you want to give a talk at Do iOS, always come talk to us, either to me, to Marco, Yolanda, Bart is in the back at the camera. We have some break time later. Definitely come talk to us to make sure that we actually get your name and that you can be scheduled for a talk. We're always looking for people. Next time we will be at the Adidas head office in the Netherlands. So that's going to be May 22nd. And yeah, look at Meetup for more information, and definitely check out the other meetups that are on there as well. But Adidas is the next one. So anything else, Marco, I need to say? Oh, wow. Yeah, we have an Apple TV app as well. We are on YouTube. We have a job board. We have a newsletter. Go to all these links, sign up, give us your time and effort, and we can do great things together. Thank you.
All right, welcome everybody. I'm Jesse, I work at Triodos. First, I was asked to give a warning to people going outside of the building, because once you get outside, you don't get inside without a pass. So if you do end up on the outside, just walk around the building and scream at us from behind the glass, and somebody will probably let you in. Let's see if I can actually skip some slides. Yeah, there we go. So the agenda, I'm trying to keep this as short as possible because we want to get into the tech talks. We do have to get into Triodos a little bit. I'm not going to do it all by myself. I've got a little clip I want to show. Then I'm going to talk a little bit about how we transitioned to native, which was a big project for us. As well as the way we work, just to share with you, and the work we do, because we have a couple of cases that we're proud of that we want to show. So this is a good place to do so, I think. A little bit about me. I'm an iOS developer with Triodos for 4.5 years. I've got 2 kids, 1-year-old, 3-year-old, and it's my first time at CocoaHeads. So hands up if it's your first time. Couple, okay, I'm not alone. Great. So yeah, welcome everybody at Triodos. One short question in between. I was curious, how many people have had the app in their hands before? So 1, 2, 3, 4, 5. The current one. Yeah. Okay, great. Not zero, but a lot of souls to be won today. So, oh, sorry, that's a little bit fast. I'm going to show a little clip that tells you a little bit about Triodos and what we stand for. And I think, well, it should speak for itself. But here we go. It's about 2 minutes.
Triodos Bank has been pushing the boundaries of what it means to be a bank since 1980. We make money work for positive social, environmental and cultural change. With our growing community of more than 746,000 changemakers, we continue to raise the bar in 2023. To tackle climate change, we co-financed 640 renewable energy projects, producing the equivalent of the electricity needs of 9.5 million households. Our share helped avoid CO2 emissions of about 6.8 billion kilometers traveled by fossil-fueled cars. We financed 338 farms, managing a total of 44,000 football pitches of organic farmland. High on our agenda is nature conservation. We co-financed 42,900 hectares of nature and conservation. Important because it removes CO2 from the atmosphere. We also want to make housing more sustainable. 19,300 homes and apartments were financed via residential mortgage loans. We finance values-based organisations in emerging markets that reach approximately 20.4 million individuals who can now save for unexpected expenses and their future. We strive for a more inclusive housing market too. Approximately 20,300 people were provided with accommodation via 217 social housing projects financed by Triodos Bank. And lastly, we financed 1,484 projects in the cultural sector, from individual artists, film and media projects, to large cultural institutions.
Yeah, so I stopped the video there because our CEO would start talking and his English is rather bad. And I think this was enough information for the current audience. I think all I really want to say is that it's a great employer. Of course, you're always welcome to talk to us about any opportunities. But I'm trying not to make this into a recruitment speech, so I want to try talk about what we did last couple of years, last couple of months, and how we do that at Triodos. So the biggest project I think that we undertook the last couple of years was transitioning to native. As a bit of background, we initially had built a native script app. Anyone familiar with native script? All right. I see a couple of colleagues nodding their head and no one else. So it's good that I have this slide. So it's basically a TypeScript and Angular platform that together creates Android and iOS apps. It's great in a sense because you have one code base. It can be a faster time to market, and there's less specialists required. Web developers, or rather JavaScript developers, I think are easier to come by than native developers. And it was great for me because it allowed me access to app development as someone with a web developer skill set. So what was not great, it's a risky dependency, especially as a large organization, to have some platform in between you and the technology that you need to provide. The UX was rather sluggish, and the native capabilities of both platforms were rather out of reach. So this is what it would look like. We have one native script code base that makes an Android app and an iOS app. And a couple of smart people got to think, okay, how can we solve this in a meaningful way without having to build a separate app alongside? and they came up with a plan to embed NativeScript in the native apps. So this was the story in Jira. Small change. Instead of having our architecture from NativeScript, we would just flip the switch, and it's going to be fine. Small project, no worries. They reserved a special ticket number, as you can see. So that was done rather quickly. After buy-in from management, there was also the project needed to then actually migrate feature by feature without our customers really being bothered by those choices and are rebuilding the whole app. And by that time we were done. We were native, and 1,000 exactly 1,000 tickets later, very coincidentally, we could finally drop NativeScript support. This was in September last year. I think that's also the point in time that we could actually move up to iOS 14 and higher support. So a very big project for us, and I think a very nice project, as I mentioned, for me myself, because I'm already I came in as an app developer, and now I can be an iOS developer and really focus on the platform that I enjoy most. So was a great project. Then a little bit about the way we work, just as information. We have 4 app teams. They all consist of 3 Android developers, 3 iOS developers, tester, as well as a product owner. And this setup allows us to make sure we have feature parity for all of our users, because as a bank, I think it's important to be inclusive of all of your users and not include some users of a certain platform earlier into certain features than others. And it also helps with learnings from the other side, because the architecture isn't exactly the same, but we can learn a lot from each other. The iOS setup, we work in a model view model coordinator setup, just to make sure that we separate as much logic as we can. We have a very expensive automated test suite. We got everything, every logic in all of the logic in the app is in unit tests. Almost all of the views are in snapshots, except for a couple of templates. We do UI testing with Mountain Bank for all of the possible flows, and we have end-to-end tests with all systems integrated for the most crucial flows, like the payment ideal, you can imagine. Stuff like that really needs to work. This is a plug for Tieme, who's going to talk about Mountain Bank in a short while. Use Bitbucket, TeamCity for CI/CD, and that's our setup. Lastly, the work we do. Of course, I've shared a couple of slides, but I haven't really shown you the app yet. Not everybody has seen it before, so. Wanted to share some examples that we're proud of. Of course, we're a banking app. We have payment platforms, but these examples are a little bit different. We have at the bottom a lot of payment features, but one of the most important features that separates us from the other banks is the Impact tab. It's our way of connecting to our audience through sharing inspirational stories, news, tips to make your house more sustainable, stuff like that. And it's trying to engage our customers in a discussion with us about what's good for the world. Then investments, we try to help our customers put their money where their heart is. And we built some good platforms for that. And there's also efforts to make that even better, make it look even nicer, get more live data. And last but not least, very recent project, actually almost live, so not quite there yet, but I think in a couple of weeks. We introduced savings goals. Of course, a lot of other banks have this feature, but we are now almost on par with them. When this goes live, we'll finally have that feature as well. And I think it's been a great way of finding out what people need in their savings accounts. last but not least, it's free to open a savings account, look around, and you can open as many as you want and find out how the app works. So small pitch there. That's it for me. I'm going to hand over to Tieme, I believe. And if you have any questions, want to get in touch, go through any of the channels or this email address, and you'll find me. Thank you so much.
Oops. Hello. Jesse, can I hand you your MacBook? Cheers. All right. Well, cool that so much people showed up today for this meetup at Triodos. Happy to have you all. I'm going to tell something about network mocking. Yeah, let's go. So I'm Tieme. I live in Utrecht. I'm a developer since 2010. I'm a self-employed contractor, and I'm now at Triodos for 2.5 years. And I love rock climbing, coding, and also open source. And this is something I want to talk about today. So UI testing is something that everybody needs to do in their apps. Often people write really large UI testing. Oh wait, I quickly want to pause the thing. Let me use this as a separate display. Always hard. Yeah, that's better. I thought, where's my notes? Okay, yeah, there we go. Okay, testing. So I want to talk about testing because it's a project that I've been working on for the last year, especially UI testing. So I think if I mention UI testing, everybody knows how that looks in Xcode and on Apple platforms. Basically, you have an app, and that goes through a couple of steps that you make a list for, and the app goes through all your steps. And this is a great way to make sure that your apps works as expected. So this is a quick demo of PocketCast, an open source iOS app. And yeah, you can see how it works. So UI testing. Who of you has written these tests? Yeah, a lot, right? And is this a familiar image when you're writing UI tests? Yeah, yeah, I know. They're pretty hard to get right. So in my experience, there are two main issues why this is so hard. The first one is interacting with the UI. The APIs by Apple look great, but a lot of times they're pretty buggy. Yeah, so it's just hard to get those tests stable. And another thing is test data, especially if your app makes a lot of network requests and relies on the network heavily. There's a dependency on your test data for your test, obviously, and if that data changes, then yeah, your test stop working or get flaky. So these network requests, they can fail when, for example, there's no internet connection. So you want to run your test, but you're on the beach. Yeah, that doesn't work. Or maybe you're on the train getting to a meetup. They can also fail when the backend that you're using for UI tests has a different API spec and it's just returning different data than your app expects. Or when the backend just returns different data than you expect because maybe you want to log in a user that's not registered on the backend, or maybe you want to register a user, but the user account is already existing in the backend. So how can we solve this? We could stop the network. But how? So in most of the apps, you write some code that's basically your network layer. And that layer uses Foundation, the NS-URL session APIs, to connect to a server. So I think there are mainly 3 options where we could take a look at how we could do this stubbing. Oh, one back. So the first one is that we could stub NS-URL session inside of our own code. So I think the second one would be to swizzle Foundation, swizzle NS-URL session, and stub it that way. And the third one is to stub the server. But before we do it, we have to remember how these UI tests are actually set up. So Xcode will create a test runner for your app, and then basically the test runner will launch your app and will execute the UI test. But the test runner can only access all the externals of your app. The test runner can't just say like app.api session and step away the session. But what we can do in the test runner is tell the app with a launch argument that it's running a UI test. And then in our app, we can check the process info to see if we are UI testing. So how can we use this? If we go for the first approach, stubbing the app's API layer, then for example, in some network code where we would access a URL session, we could say, okay, if the process info arguments contains UI testing, then we're going to use our stub session. I had arrows there. But yeah, this has some downsides because you have to add a lot of testing code and stubs to your app sources. And yeah, that's not ideal. It's also not very flexible because you want to execute a lot of UI tests, but yeah, then you have to preset all those stubs in the code. Yeah, it's not ideal. And also your stub session is not the same as URL session, so it will behave differently as error prone. So we could also swizzle Foundation. We could check in the app delegate or somewhere else where you set up your network if you're UI testing, and then if so, we could swizzle it. There are a few libraries for this. I found 4, but there's a lot more. So this is an example of one of them. We could say, hey, if the host is list.pocketcast.com and the path is trend.json, then we're going to return this JSON instead of making a real network call. This has the upside that we can leave our API code untouched, except for this in your app delegate or somewhere else. But you still have to add all those stubs to your app sources. And it's not so flexible because you still have the problem of predefining all your tests here. So I think there's one other interesting option, and that is to stub away the server. So we set up a stub server, and we set up all the stubs that we want the server to use. And then we point our app to that server instead of the real server. And the cool thing is that it almost needs no changes to our source code. I think it's pretty easy to set up as well. And it's really flexible because in our test runner, we can create the server and we can reuse it for every different test. But yeah, then what stub server should we use? I did a Google search last week, and there are quite some stub servers. And I really had to laugh at all the puns on the word mock, like this smoking or mockadillo. But the one we're using at Triodos is called Mountebank, and I want to tell you something about it. So Mountebank is a project by Brandon Byers, and it's basically a platform for mocking network requests. You can use it to configure your servers. It's standalone. It's lightweight. This clicker. It's open source and it's free. And it runs on Node.js. So the installation is quite easy. You just say npm install global Mountebank, and then you can start it with mb start. So how does it work in your test setup? If you have your Mountebank instance running, then from your test, there's a REST API you can use to set up a server. So you call the REST API with your stubs for that specific test. And then Mountebank will create a server for you. And Mountebank calls these things imposters. So we have our stub server running. And then when that is created by Mountebank, Mountebank will generate a random port where the server is running on. And then the test can launch and configure the app with that port that the stub server is running on. So for example, port 4010. So then when the app sends any request, it will send them to localhost 4010, and then the test server will respond with the stubs. So then in the imposter, there's a selection that takes place to determine which response needs to be sent back to the client. So when the app makes a request, for example, podcast.json with some header, then the imposter will check which stubs it contains. So here we have an imposter with 2 stubs and a default response that will just always triggers, always returns if nothing else matches. And let's see how this works. So these predicates, they have request fields, and they basically match against incoming requests. And the response can be anything, like JSON, image, some binary response. So first, the imposter will check the first stub. So the first stub has 1 predicate, and the predicate basically checks, hey, I've got a method, it should be get, and a path discovered.json. So in this case, the path is different from what the app is requesting. So the imposter will then take a look at the second step. And this one has 2 predicates. The first one is a predicate to check the method and the path. And the second one is a predicate to check the header. So in this case, they both match. And the stub will select the first response to return to the app. So then the app can make another request. So, So then the app, so the imposter will return the first response. So in this case, a 200 with the response, a list of podcasts. So then the app makes another request. But then the second time, the same predicate match, and then the stub will return the second response. And then when the app makes another request, it will return the third response. And those responses can be different. So the third time, it can return a 500 status code, for example. So this project works great. And there's a nice REST API. But the downside of that REST API is that it's JSON, it's not type safe, and it's a lot of work to set up all your stubs. So that's why we created Mountebank Swift. So a year ago, Mathijs and I, where's Mathijs? There. We started working on this project. Triodos was already using Mountebank, but the implementation was rather small, and it was not including all the features that Mountebank had to offer. So then on one of the POC days of Triodos, we decided to see if we could open source this project and just write it from scratch. So now we're working on it for about 10 months, and we created a full API that sits nicely between your tests and the Mountebank instance. So let's see how this works and how you can integrate it into your project. So the integration is quite simple. In Xcode, you just say file and you add it as a package. And then you add it to your UI test target. And then in your test, you do the following. You create a Mountebank client. And then in your test, you create an imposter with a list of stubs, and you post imposters to Mountebank. And then in your app, when you launch the app, you basically say that you're UI testing, and you pass along the server that it's running on, and you say launch. So I created a small demo app to demo it today. It's a really simple app. It uses those APIs from Pocketcast, the app we saw earlier. And it has a list and has a detail page. It uses 2 endpoints. And we're going to see if we can add a error handling UI test. Let's see. All right. Is this legible? That's good enough? Yeah, right? Okay, so I already showed the host file where the hosts are listed in the app. But let's first import Mountebank to the project. So normally you would type in here the URL, but it's already listed here as the recent one. So let's add the package. And then I'm going to add it to the UI tests. Hopefully the Wi-Fi will help me. Yeah, all right. OK, and now in the tests, I can import Mountebank. There we go. And I can create a client. Oh. And we can choose the port number, but it's by default just running on 2525, so that's fine. Yeah, let's start it because we need to use it. So I say mb start, and I'm going to say allow injection because we need that later on. So now we can create a list of imposters. So let's say imposter. So you can choose a port, but we're just going to let Mountebank decide a port. And we're going to use this one for the list, not the codable one. So let's just say lists. And then we're going to create a list of stubs. So the first one we're going to create is just a stub. Nope. With a response. And this is going to be an is response with the status code of 200. Oh, well, let's say 500. Yep. And then this needs a predicate as well. And this is an equals predicate. Oh, come on. Yeah, should be good. Ah, thanks. Always good to have a live audience helping. All right, equals request. Oh. So we want something with the method get, and we want the path that starts with trending.json. We don't need the options. Yeah, this will run fine. Okay, so now we post this to Mountebank. Try await Mountebank post imposter. And then we want to know on which port it is running. So let's get that port out of there. And then, yeah, here we can just return or fail maybe. All right, so now we got the port. So now on the application, we can launch the application, but let's before we're going to launch it, let's add a launch argument. UI testing. And in the environment, we're just going to say lists API host, localhost, HTTP, and then the port. All right. Column, thank you. Nice. I want this in my day job. Okay, so let's run this. But before we run it, in the host file, I'm gonna check if we are UI testing. So if UI testing is UI testing, this is a Boolean. Oh, other things. So we're gonna check the process info. Arguments contains UI testing. Yeah, and then if it's UI testing, we want to extract that host. So we say list API host, URL. Oh. We also get it from the process info, from the environment, and then as the key list. Did I call it lists? I think so. Lists API host. Yeah, and if that's set, then we're going to map it to url.init. We're going to flat map it to url.init. And then this is going to be optional. All right, and then when we're returning the list for that's been used everywhere in our app, the host, we're going to say list API host. Actually, let's call this UI testing list API host. And if it's not set, then we're just going to return the production one. Yeah, let's make these static as well, because we don't need to make it a regular one. Okay. So I think all should be good now, and we can run this and see. I've got all these clones here. Which one do we need? Yeah, this one. Okay, so the app indeed now says something went wrong, error 500. That is what we returned here, so that's good. So we can assert now, xct assert true, that some static text in our UI test will contain error 500. That exists. And after that, we can tap that retry button and return a different response. So let's change this from response to responses. Oh, come on. Oh, there. And this time, we're going to return a 200 response. And as the body, we're going to return some JSON, not a string. And in here, we're going to return a podcast list that is empty. So we can, in our UI test, verify that the error handling for empty list of podcasts also works fine. So let's do this. Let's call the retry button. Let's tap it. And then we would expect the screen to say no, was it no podcast found? Yeah, no podcast found. Let's just add a sleep of 2 seconds here so we can actually see what is happening. Something went wrong, tap retry, no podcast found. Nice, that works. So let's add one more response, but this time let's add a full list of podcasts, because that's what we're interested in. So previously I was using just a dictionary as JSON, but we could also use codable responses here. So we have this model object feed that contains podcasts and a list of podcasts basically in there, just a struct with some arguments. So let's say body is feed with some podcasts. And then in there, let's create a podcast. With some arguments. So let's call this one CocoaHeads. And the author is Dutch iOS devs. Some description and ID, I don't know, 1, 2, 3, 4. And the URL is CocoaHeads.nl. All right, let's see. So if this works, we would expect to see CocoaHeads. Right, that was the name of the thing? Yeah. All right, let's run. Something went wrong, no podcast found. CocoaHeads, nice. All right, but it doesn't have an image yet, so let's see if we can get an image as well. So we could do two things. We could just add another stub here to our imposter. So we can say stub with a response and a predicate. Oh. And then this time we're gonna say is status code. Come on, 200 and a body. So here we want to return the data for this image. So I think I've already created an image here, and I created a small enum to load the data from disk. You could type this out as well if you want. For now, let's just say example data.jpg.data. And then for the predicate, we're not going to use an equals one. We're going to use a matching one, which uses a regex. Request. As a method, we're going to say get. And as the path, we're going to say /discover/images, because that's, I think the full path is something like discover images / the ID that's actually here. Okay. So we could add this stub here and use the same imposter for both of the hosts of the app. But let's just create a new imposter for this one. So let's rename this one to list imposter and this one to list port. And then copy over everything that we have. So let's name this one images imposter. So we can separate the two servers that we create. So let's see. So this should be images port. And then we're going to create a second host, images host. We're going to have that port there. Make sense? I think so. So in our hosts file, we're going to duplicate this. DUI testing. Come on. Images host, and then this is also images. And I think that should be kind of it. So let's run this thing. Fingers crossed. Something went wrong. Oh, I thought something went wrong. And then we have an image from a different stub server. But it's really easy to create these servers, so it's not that much of a hassle. And the nice thing is that we don't have a dependency on one global test server where other people might also be testing on, or where our other tests are running on. So yeah, we don't rely on other tests to first run, or we don't rely on setting up that global server somewhere. And we can run our tests in parallel as well, because every test has its own port. So I created 2 more tests, and I think I used the same hosts here. No, I called this one static. Yeah, it's not really handy. Let's see, is this one also static? Yeah, so let's quickly rename this one to static to match the other test that I created yesterday. There we go. And I think if I would run them all now, you can see that we have 3 tests in parallel that can all run together on 6 different stub servers. So the first one is the one we just created. Then the test on the right opens a web view, which is also stubbed. And then the one in the middle just opens the podcast view. So yeah, I think that was the demo. I think it's a pretty nice setup. Yeah, that's there. So I have to unmirror. All right. So advanced usage. So now I've just shown HTTP, but you could set this up with HTTPS as well, including certificates, keys, whatever your app requires, SSL pinning. I just didn't do it in the demo, but there's also mock verification. So it's not only stubbing, but also mocking, because you can actually afterwards check which requests are made to your stub server. There's also some advanced predicates. I've already showed you the equals and the matches, but there's also not, or, and an and predicate, and also an inject predicate, which you can use to inject JavaScript to dynamically check if a predicate should match. So this one would match half the time. Then there's also a couple of advanced responses. So we use just a is response to just return a basic response. But there's also fault, which could just send some garbage or create a timeout. There's a copy response, which could create some copy, which could copy some stuff over from your requests to the response. or a lookup to go to some database and fetch some stuff there. There's a shell transform response, which could execute something on the shell and return that dynamically. And there's also an inject one, which you could use to rewrite URLs, for example, in a payload, or put something from the request in the response. There's just a plethora of options that you can do here with the inject. And there's one more very handy feature that we merged a week ago. I think it's really cool. It's proxy mode, where you can basically say any request that the app makes to the imposter, we're just going to proxy to a real server. And then when the server returns the response, we're going to record that response. But we're also going to generate the predicates that you actually need to do this. So how does this work? So when your app makes a request to the imposter, then the imposter will create a predicate based on that request. So for example, you create a predicate generator that will create predicates for the method and the path, just like I just did. And then when the app makes a request, a predicate will be generated for that method and that path. And then the imposter will send the request to the server. The server will respond with the request, and that will then be recorded. And when the app then makes another request, and then it will be sent back to the app. And then when the app makes another request, another response is recorded. And when the app makes a completely different response, then another predicate is created. And the cool thing is that once this is done, you can just write all those stubs to disk, and then you can reuse them again. So let me show you that as well. So we had our test. Let's just copy paste this, because a lot is the same. Let's call this one test feed. But then instead of using a stub here, we're gonna, oh no, we're still gonna use stub. No, response. We're gonna use a proxy. And this thing is gonna proxy from lists, lists.pocketcasts.com. The only thing is that this server returns everything gzipped, which is not so handy. So we want to inject a header before we're gonna send it off to the server. So there's this header, accept encoding identity, which will let the server know, please don't gzip any response that you're gonna send. So let's send that off. Let's format this a little bit. There we go. Oh, almost. So then you have this proxy here. Let's see, do we need anything more here? No, I don't think so. So let's just call this thing list proxy. Oh, come on. It's not, something is complaining. Do I need? Oh, thanks again. So this is fine. And then for the image, we're basically going to do the same. But then for the images, we go to static, and we don't need those gzip headers. So we're going to do everything the same. Our app is not going to return a 500, of course. We're just going to sleep. And then just for 2 seconds. And when it's done, we can use the same ports to get the imposters again. So say try await mountebank get imposter on the port list port. There we go. And then we can say write stubs to disk. That's one. And we want to do this for the images as well. Images port. I think that's about it. So let's run this test feed thing. So now it will get the real server. So we will see different podcasts with different images. And as you can see, I hacked this last week, and the images are still duplicates somewhere. Doesn't really matter for now. The point is that they should be saved now somewhere on disk. So let's see. An imposter folder has been added to the same directory as the test, and in there we have a list. We have a list of everything that the server returned. And if we collapse the body a little bit, you can see that it. Yeah, it didn't use any predicates. I forgot to add those. So let's. Already wondered if I was not forgetting anything. So let's say predicate generators. We want a list, and then we want a predicate generator dot. So we can use the inject to create one dynamically, but we want the matches in this case. And then the fields, we want to record the method, true, and we also want to record the path, true. And then the operator, you can switch it from equals to those matches or and or whatever. Case sensitives, we all don't need these options. So let's see, formatting is a mess, but it will work. So let's again run the test. There we go. And then once it completes, how long did I sleep? 2 seconds. It should have updated this list. So it created a predicate, one for the method and one for the path. And the images as well. So yeah, base 64 encoding for images is not ideal, but it was the best we could do to represent it in text. I think maybe in the next iteration we could actually write them to disk as images, but yeah, for now this works. So the cool thing is that we can now switch these, so they are written to disk as an extension of our own test file. So and they use the name that we used here. Yeah, so the name list proxy was not ideal in this case, but let's see. I can now say self.test feed stubs for the list proxy. Yeah, that's an array. Don't need this one here. And we can also say self.images. Yeah, so we don't need to write to disk anymore. Yeah, so let's run this. Yeah, well, basically it will look the same as before. Oh, where is it? Yeah, and I think it will show the same image for everything. I think somebody, but it's in the UI Swift UI code of the thing. I just hacked it in there. Somebody should take a look at that. But this is a really convenient way to set up your stubs for your UI tests. So there was one thing I just forgot in the other demo that I wanted to show. That was the assertion of the actual request. So because we splitted this up, we can also use it to let's see. I just removed this line. Yeah, that's what I wanted. To get those requests. So let's say requests here as well. So these are the list requests, and these are images requests. And then we can assert that the list was actually fetched. Well, we did 2 times retry, so it should have fetched it count 3 times. And the images, we had only 1 here, so let's add a couple more podcasts. Created a list earlier. So it should have 4 images now. So the images request should be 4. Yeah, and then we're now just asserting the count, which you could also assert anything else in the request, so the headers or the query parameters or whatever you want. So let's see if this runs. Yeah, and it returns 0 because I forgot to actually say that we want to record requests. So let's run again. Will it work? Yeah, there we go. Yeah, so that was it. Anything I forgot this time? Nope. Okay, so let's go back to Keynote. Yeah, so far I've only been talking about UI tests, but this is also very handy when you're giving a live demo, for example, for a sprint review or for something else, and you really want to make sure that the right data is going to show up in your app when you demo it. Or when you want to reproduce an issue where you know that the backend is returning a specific payload. Or just for development, when you want a stub server for your development workflow. So at Triodos, we now have over 200 UI tests with a total of more than 400 stubs. Yeah, and it works great. So to summarize, there's a link to the project. I think it's really easy to set up. And you have full control over your test data and over the test data for your tests. It's really flexible. You can assert the network requests that are made to your stub servers. You can record and replay any responses. And I think it will lead to more stable UI tests. That was it. You can follow me on Twitter for... You can follow me on Twitter for any updates on the project. Yeah, and if you want to work with me or want to learn more about this, please reach out. That was it. Any questions?
Okay. I didn't know about this thing. So, right? I have to speak in it.
Yeah.
So my question was about one of the last steps you did by saving the responses to disk. Is this actually just, you're actually completely skipping Mountebank at that point? You're just returning responses that you saved right on disk. Is that true?
No, so when you create the proxy, a proxy stub, then Mountebank will perform all those requests to the real server, and it will store everything in the Mountebank instance. And then when you get the imposter again and you write everything to disk, then you're just serializing it from a JSON response back into Swift objects.
Okay. So how easy is this to set up with a CI/CD pipeline?
So you want to do the recording in your CI pipeline? Or what do you mean?
No, the replay, the test.
The replay. Well, so I think when you're developing, then you would use the proxy to record all the responses. And then you have the responses in your project. And then when the responses are in the project, just regular stubs, then they're just UI tests, and you can run them locally on your machine or on the CI. So the only thing is that you have to make sure that on your CI, you have to start this Mountebank instance, right? So you have to, depends on which CI you are running, but you have to say mb start, and then run your UI test. Yeah.
Okay, thanks.
Thank you. So my question is about the speed of UI tests on CI, because recently I think in my company we removed mostly all of the UI tests because it takes so long on the CI. And how do you find it with this setup?
Yeah, they obviously take longer to run than regular unit tests. But it really helps if you can run them in parallel, because then you can just utilize all the cores of your machine and run them together. Mm-hmm. And when you write them, you have to keep in mind that what you're doing. So don't try to duplicate stuff or do stuff that takes a long time. But they will take a little bit longer than unit tests.
True. One other thing that you mentioned with other ways that it's not flexible, and you mentioned that you keep JSON on the project file, but you also did the same here. So
yeah, correct. But if you you saw that in Xcode, the stubs were actually in the UI test folder, right?
True.
So you don't have to put them in your project. And because when you're starting each test, then you can basically send those stubs to the stub server. So if you would have them all in your app binary, you somehow have to know which test you are running and then start the stubs that are necessary for that. So you have some kind of double administration of which stubs you want. And it's not like now you can organize everything in your test file, and then you have to put stuff in your sources as well.
Yeah, true. Awesome, thank you.
Yeah.
Do we have time for one more question?
Hi, thank you, Tieme. Great project. It really looks very helpful. I was wondering about one thing. You changed, at least it seems like that, you changed your main source code to allow this test network.
Yeah.
Or did you do that in the test project?
No. So yeah. So that's indeed in the
So why did
in
you
the
do
sources.
that? Why did you do that in the application? Why don't you just inject the server?
So the question is, where are you going to inject it then? So what I would do in a production application is obviously you would say like if debug here, and then something like this, and then for non-production, like for production, you just want to return nil here to make sure that like these test hosts are never gonna get to your production code.
Oh, what I mean is, so in your production, you start the service with the default value.
Yeah.
And then if you're testing, you start that service with a test service. So you don't need to change your main code at all, except the injected server.
Yeah, but the question is, where are you going to inject it? Because in your test runner, you don't have access to the internals of your app.
But you do have access to the application, right? Your
Yeah.
application. So you can just inject it there.
No, you can't.
You can't? Oh, okay. That's my mistake then. Thank you.
Yeah.
That was like one discussion, not one question. Thank you, Tieme. We have time for like a little bit of a break so that you can have like some time with your own thoughts while you're going to the loo.
Yeah, and we got dessert.
And we have a dessert actually.
So that's like where you got the food. There's I think it's cheesecake.
Okay, so better run for it.
Yeah.
right word. Anyways, I'm hoping that we can learn a lot about these devices and what they actually are meant to be according to Apple. And yeah, just like put them on, guys.
Thank you very much. Thank you for hosting us here at Triodos. I'm Mathijs, and this is Tom. And together with Tom, I run an indie company called Nonstrict. We create apps for macOS, visionOS, whatever Apple platform we feel like making an app. I think the best running, most famous app right now is, well, depends on the market probably, but is Bezel over here that can mirror your iPhone. We create a visionOS app, split screen, that creates an extra virtual display of your Mac inside visionOS. We do that together with Jordi Bruin. And we also do other random stuff like writing blogs about technical stuff on our website. And we're currently also working on a not yet released SDK to do screen recording, camera recording, all kinds of recording on macOS in Swift and Electron apps. So that's the stuff that we work on. And first I was wondering how many of you did already see a vision device for real before today? Okay, quite some. Nice. And how many also did actually try them on and have to experience them? Okay, that's already a little bit less. And how many people did try developing for visionOS? Running something in a simulator, creating an app? Okay, cool. Anyone watched WWDC videos about it? Not developing stuff, but okay, cool, nice. So quite some interest, but not too much people having had their hands on them. I think Tom and I were really excited when Apple announced the Vision Pro at WWDC 23. We were working on Bezel already for quite a while. Oh, my Mac is already going to sleep. And Bezel is mirroring your iPhone on your Mac. I don't know where I wanted to demo it, but I left my cable somewhere over there. So I think I skipped the demo. It's mirroring your iPhone on the Mac. That app was already doing pretty well, and we were thinking, well, maybe that's something that we could bring into visionOS. Mirror your iPhone inside the virtual environment. But I think one thing that's very hard about such a new device is that you don't really know how it feels when you use it. I really had the same when the Retina display came out for the iPhone. It sounded really cool when it was presented on stage, but it was like, yeah, okay, it sounds good, but I have no idea how it feels or what it looks like. And once I had it in my hands, it was like, oh, okay, I never want to go back. And the vision was a little bit of the same. So we had a lot of concepts and ideas, like we could create this, and it would be really cool to be on a new app store on day one. But with what app? So Bezel was one of the ideas that we had. We submitted it to Apple to go to one of their developer labs in London. We were invited. We actually went there. And that was the moment that it really clicked, like, okay, what's this device going to do for me? What's working well? What's working not so well? Where are problems that we maybe can solve with our apps? So that was a very interesting moment, I think. And I hope with demoing the Vision today and walking through some features of the Vision Pro and visionOS, that we can also show where the pain points, what are the strong points of visionOS, how does it work to develop an app for visionOS, and maybe give you some ideas what you can do and what you can build. So I think that's an interesting thing to do. Let's see. So maybe we just switch to the headset, Tom, if you can put it on. So I think what I found very interesting at the lab was also that the first instruction was also not to pick it up like this, because this is a magnetic thing that just comes off. So if ever someone hands you a vision, don't take it by the soft thing, but take it like by the front and by the back. That's the solid parts that you can use. The vision is a pretty hefty device when you put it on, and I think that's something that they can really still improve on the vision. Yeah, okay, so here we have a mirror. So one thing that the vision does is it only renders sharp where you look. And when you have the vision on, that's not something you will notice. But when Tom is demoing and we're looking at the mirror, we're going to focus on other points than where Tom is looking. So it will look blurry. But that's not something you will see when you have the vision actually on your head. So I think that's good to realize. I think if you've seen any video from Apple, then you've seen the pass-through. The pass-through is pretty good. It's pretty high quality, but as soon as you're in low light conditions like here, then it will feel a bit grainy. And if you look at other screens, the screens won't look as pretty as normally. I don't know, if you look at your laptop, then probably will also see that it's not super readable. So that's something that's a bit hard. Nice. So Vision OS also has just a home screen, like every other Apple device. Even your Mac has a launcher that I never use, but it's there. And you can just launch apps from here. Look at it with your eyes, tap it with your fingers, and an app will launch. It really feels like, the first impression I had in London was, it felt like using an iPad, basically. The iPad apps are floating in space. That's the first thing that you will notice. So this is the Settings app. Settings app looks really familiar, I think. You just use it like any other Apple Settings app. So that's pretty easy to use. Safari is another interesting app. That's basically Safari, but then floating in space. But they do nice tricks like this. So if you look at all the tabs that are open, they can expand into space. And that's one of the most interesting things that Vision has. It's all around you. You can just use all that space as an app or as a user and place windows around you. That really is convenient to do. Personally, when I use the Vision and I'm seated, so when I use it for work, etc., then I do feel you can have 3 windows next to each other, but then it becomes inconvenient to just turn around. So then there is still a limit in how many windows you can have open, and the windows are pretty big. And window management is also a bit hard. So as soon as if you have multiple windows and they start to overlap, then you have to actually look at the window behind that other window to get it back to the front. So there are still weird things, and I think Apple is improving rapidly already in Vision OS to improve upon that. One of the coolest things that Vision can do is show 3D models. And it's really hard to demo this because we're still looking at this flat screen over here, and it will look way different than Tom is experiencing inside. But if he opens a USDZ file, let me move over here that I'm not constantly in the shot. Then this really feels like that object is actually over there. You can walk around it. You can tap the little dots to get more information. It's animating. And what Vision Pro is also doing is it's looking at the light of the room and applying that light to that model. So it really feels like the model is actually there. If there's a lot of sunlight coming in, it will look different than it's doing now. So that's a really interesting experience. And this also was one of the things that I've really felt was something that I'd never experienced, that you can place an object inside the real world and that it feels like it's actually there and that you can actually use it. That's just a really interesting experience. It also feels hard to work with as a developer. Like it feels like, okay, now I need to have all kinds of 3D skills, but I think that Vision Pro does a pretty good job of making this easy for you. We can look at some code samples later to show how it works. You can also blow them up pretty large. So that's pretty nice. Yeah, so I think that was one of the experience that we had, that we were like, okay, 3D objects, that's something that's really interesting to have in a Vision app. So working on Bazel, I was like, okay, if we can have a 3D model of an iPhone in there, then it will look really realistic with all the rendering that iOS or Vision OS does for us. So that's an app that we created. Well, you have all the 3D power that I was already talking about, but the normal screens that you have are simply SwiftUI or UIKit views. So if you're already used to creating a Mac or an iPhone app, it's really convenient and easy to create those UIs. It's just the same paradigms that you're used to, that you can use. So basically everything you see in our app is just 2D SwiftUI code. The only 3D model thing is a 3D model that we bought on the internet and didn't create ourselves to have an actual iPhone here. So you can now look at the side, a little bit at the side of the iPhone and see that it actually has depth. And it also has a little bit of a reflection on the side. And that makes it feel really, really interesting and really special. And you see there's like a glass panel on the back. So it's actually on a 2D, the 3D iPhone is on the top of a 2D window. So what you can do if you have a normal SwiftUI view is you can just add a 3D model like it's a normal view in your app. And then SwiftUI and Vision OS will do the rest for you. They will do all the fancy rendering, make sure it actually comes out of the view and is rendered properly. So that's actually pretty cool, that you can make those super realistic feeling views.
Well, I mean, for the developer.
Yeah, so it's a lot of normal app work. And what we did is position this, the screen of the iPhone, position that in a Z-stack and pull it forward a little bit so that it's the right depth. But that's basically it, and a lot of clipping to make sure that none of the view is sticking out of the 3D model. But that's basically it. So yeah, those are pretty cool things that that you can do. One of the other things that we pretty soon noticed when using Vision Pro is that a lot of other Apple stuff can connect to it, like phones, laptops, etc. But if you don't do that, then just use the Vision Pro, and you have to type. For example, you go to Safari and you want to go to The Verge or something, or some other website. Then you get this keyboard floating in the air. You probably have seen this also in some demos. And that's pretty inconvenient to type on. So typing a URL is already, well, okay, now you can manage, but I'm always making typos also. And you have to touch in air and you don't really feel the feedback. You have audio feedback, you hear ticks, but this is not so convenient. So you can actually pair a Bluetooth keyboard, for example, or if you use your Mac and have that mirrored into the Vision, then you can also use your Mac keyboard to type into Vision OS app fields. But yeah, this is really not an ideal solution. So that's also something we created an app for, to say, well, okay, you have this device in your pocket that you've always with you. Why can't you type with your iPhone? Like the Apple TV remote app that's also helping you to type on Apple TV. So we created an app called Typos. That's actually on the App Store, if you can find it. I don't know why there are no results. Maybe the mock server is still running.
Typos.
Yeah, just try refresh. I think the third goal. Yeah.
Does it support multi-touch? Or can you just
On the
type
keyboard?
with one finger?
You can type with 2 fingers. If you will type with 5 fingers, it won't work. But you can type with 2 fingers.
Your, index fingers.
Yeah, and use your index fingers. That will work. That's, I think, the.
What you can also do is look at the keys and tap.
Yeah, and tap in the air.
So I can look at each key individual. And that also works. Some quicker sometimes than tapping. Depends how familiar you are with looking at specific small items.
So one thing when you do UI designing in VisionOS apps that you need to be aware of is that everything in VisionOS is a little bit bigger. So I think the recommended size on iOS was, what was it? 44 pixels. For VisionOS, they sized it up a little bit to, I don't know the exact number, but 60. 60 or something, yeah. So that the minimum size for things is bigger. There also always is more space between items because you have to focus with your eyes. So if you look at something and it's too close, then for your eyes it will blur together. And for the vision engine, it's not clear what item you're looking at, and then the focus will go up and down to the different items. So those are design things to notice. So one app we made is a typer. So Tom is now typing on his iPhone, and we're using the networking APIs from Apple to find the other device, and then just send over the string that he's typing, and render it over there. And what's pretty nice is that this is just a simple SwiftUI view with a state binding. So the new string is coming in. We push that into the state. It's rendered over there. And then we typed dot draggable on it. And if you type something, then you can pick it up. You have to do that carefully. Yeah. And then you can let it go in a text field, and then it's there. And I think that's pretty nice because draggable is also something that you can support in your iPad app or on Mac, for example. And those SwiftUI patterns that you learn on other platforms are also things that you can apply here. So that's pretty nice and convenient. We also created a copy button that you can just copy and then paste somewhere with a nice sound effect. So those are also things that work pretty well and pretty easy. So that's fun. And I think what's really fun for such a new platform as VisionOS is that a lot of stuff has rough edges. There's a lot of stuff that you can't do. It really reminds me of the first iPhone, and you couldn't copy-paste stuff, etc. So everybody is thinking of smart utility apps, little novel things, confetti cannons, stuff like that, because it just looks really cool when you're just now walking inside a big blast of confetti. A lot of that stuff is really fun to do. It's like the beer drinking apps on the iPhone in the early days. So that's also stuff that goes around, and people are playing with it. People are buying those apps for a few dollars. So that's fun to do. So if you have an idea for Vision, I would really encourage you to just try it out and put it out there, because the store also is small. People are looking for fun things. Just try stuff and see what sticks. Nobody knows what's working. I think that's a big difference between developing for iPhone. iPhone has now been around for years. There are established patterns. We know how we should solve certain things. But those patterns that we now have on iOS were invented and evolved in the early days. Like pull to refresh was something that was invented also by app developers and then adopted by everybody. And now it's a standard thing. And those things are now being invented on VisionOS, and you can be part of that trying out, playing around, and figuring out new stuff. So this is a panorama picture that Tom is looking at. It really curves around you and looks really nice. you can really be, and that's something, of course, of a VR headset. You can really be inside things instead of only look at them on a small screen. So that's a pretty interesting and fun thing to do. It's also not only native technology that you can use to develop stuff like this. Unity developers are also deploying their apps on here, but you can also use web tech. So there's WebXR, which is an open standard that's also supported by Safari. And you can choose, this is a demo site with a dozen of demos of WebXR stuff. And that's all. You can also just launch that. You have to confirm with the pop-up that's okay for the website to track your hands and take over your environment. And this is just only web technology that's now taken over the full vision experience. So Tom can't see us now. So stay still, don't bump into my laptop, please. And it's also tracking your hands. Yeah, so now, Tom, that's also interesting. If you go close to objects, and when you start walking, when you're fully immersed, then it will break the immersion to basically keep you safe. So this is also pretty cool and pretty interesting that you can use technologies like this and experiences like this to try stuff out, or maybe other experiments that you find on the internet is stuff that you can use. I think one of the demos Apple gave to this journalist in the early days was a butterfly and a dinosaur demo. That's also a pretty good and cool demo if you happen to try vision. Look at that video; it's really impressive, and it's also cool to see that the butterfly actually fly in the room. I think another example, a good example of 3D objects, is also JigSpace. Maybe you can launch a nice jig with a jet engine or something. That's also a really cool thing. If you can now place a 3D object, and in this app you can just pull the whole thing apart and look at the jet engine, how stuff works, what it does, get explanations, etc. And you really feel there is really depth, and you can walk around it, and that's also a really interesting experience. Maybe if you tried something like a Quest, and you can also have experienced something like it. But I think the quality in the vision is pretty high and pretty interesting. So that are also
this one's more useful in case you need to build
also a bit more boring
standing desk. You can figure out how to do this.
Yeah, you have a
this is
standing
way better
desk
than a fold-up paper instruction set.
Yeah, exactly. What also is really weird is that other people are just walking right through your 2D objects when you have them on, and they're not really respectful of anything that you use. Let's see. Oh yeah, what I wanted to mention is that something you also can't really see in the demo, but the audio is also really good and also spatially positioned. So you really can hear where things come from. So if you place an app to the right of you, you really will hear the sound of that app coming from that position. And that also really helps to orient yourself. You can also put on an environment to close yourself off. That's also really neat, especially if you're in low light conditions and the pass-through goes a bit grainy. So then it helps to put on an environment. So Switch Splash is one of the demo apps from Apple. The source can just be downloaded. You can just look at how it's built. There's a lot of Swift UI code with some 3D models. It's really fun to do. You can build a water slide for a fish that's in that bowl, and then actually let the fish slide through the water slide. So those are pretty fun 3D things, and I think the interesting thing here is that Apple has created quite some of those examples which are pretty interesting to look at. because to me it felt pretty daunting. Like, okay, it's all 3D and it feels really game developer style. But if you look into the source of those apps, I think it's really doable. You would have to have a 3D modeler or something next to you, but the coding is pretty doable for any iOS dev, I think. And I think one very useful thing that a lot of people will use is mirroring your Mac into the Vision. So what should happen if you look at your Mac is that a button will appear that says connect. That's not always working. I think your laptop is under an angle, Tom. Maybe look at my laptop, then it probably will think that's your laptop. No, not working. So you can luckily also pull it up by Control Center. So Control Center is always hovering on top over there. So if you look up, then a little dot will appear, and you can open Control Center and also do things like start mirroring, etc. So this is Mac Virtual Display. So the screen of the laptop is now turned off, and the screen is only visible inside Vision. And it's a pretty convenient way to work with your Mac. So if you develop a Vision OS app, then this is my preferred way of working, mirroring Mac Virtual Display, and then having the app on the side and building and running it so that you can actually test it in the device. It's also pretty doable. So the first app, like Bazel, we fully built in a simulator. We had one day in a lab to try some stuff out, but that was it. Other than that, it's fully built in the simulator. That's really doable, except for moving around. And I don't know if you tried the simulator, but if you have to move around and click on stuff, that's really inconvenient. So my recommendation is to connect a game controller, like a PlayStation controller or something, to your Mac, because then you can use the game controller to move around, just like in a game, and then click around with your mouse. That makes it way easier to develop in the simulator. And that's pretty doable. The only thing that you won't catch in the simulator are the weird bugs that you only have on the device, and those are still there because it's a first-gen device. So that's the harder stuff. But Bazel is also an app that we created in the simulator, and it works pretty well, except that the screen sometimes turned black for some unknown reason that only happened in the device that we had to troubleshoot. So here is some code. Is this the Splash?
This is the Hello World app.
Oh, the Hello World app. Oh, yeah. So there's also a Hello World app, which shows stuff about the solar system and planet Earth. A little informational app with also 3D items. And what's pretty interesting is that this code is actually pretty boring, so to speak. So it's just a Swift app. The World app is a Swift app. We have a scene. If you've done a Swift UI app before, then you've seen this. One of the things that you will notice is that there are multiple window groups, and there's an immersive space over here. And that's something that's used a lot in Vision, so it's convenient to open multiple windows, like on your Mac. And the immersive space is a special kind of scene that you can turn on, and then will take over everything else. Then it will push away all the other apps. You can choose if it should also occlude everything, so it should really be like you're on the moon, or that it just pushes away all the other windows, and then your app can use all the space around you. But within those views, you just use navigation stacks, Z stacks, because Z stacks now actually have depth. It's not only what's on top, but also you can also push something to be more in front or more to the back. V stacks, H stacks, animations. It's all working like you would expect in a Swift UI app. So that's actually pretty great because it makes it really easy to build the app and then focus on the actual experience that you want to deliver and try stuff that you can do. So one of the things that you wouldn't really do maybe in an iPad app is add a 3D model. So that's maybe interesting to show. So the thing to the right, I think so here we have a 3D model of Earth. You can walk around it, look at it. You can, with the little buttons on the bottom there, you can also make it turn around, change the tilt. That's stuff that you can do with this. But if you want to add this 3D model to the view, then that's pretty easy to do. So maybe, Tom, you can, this is a 3D satellite on top of a 2D window. So there is another new Swift UI view called Model 3D. And you can use Model 3D to add 3D models to your views. And it's a lot like loading an image. So you tell the thing where to load it from your bundle, what's it named, and what bundle it should be loaded from. And then once it's loaded, it passes it in here, and you build a view that the model should have. And it's also async, so you also have a placeholder, because it needs to load. It has to load the 3D model, the textures, etc., do the rendering. And once it's ready to show itself, then it will call that closure and that callback, and then you can put it in the view. One of the things that's a UI element that's special to Vision OS is the ornament. Those are the little small buttons that we saw at the bottom of that planet Earth. So the bottom controls here, that's called an ornament. And that's something that you can also add to your views. They are used instead of where you would use a tab bar, for example, on iOS. Then they're often to the left. For example, the Photos app uses that here. And you can, and at the bottom, that's also an ornament. The ornaments are pulled a little bit to the front and a little bit outside of the app, so that you have more room for the content to show. Anyway, they really feel like a part of the app, but also like separate controls. So, for example, music also uses an ornament at the bottom to show the what's playing right now and the controls for the player over there. And an ornament is also something that you can add to your app pretty easily. So you have a view modifier .ornament. Do we have that here in the app? I don't know. Should be somewhere probably. You can type .ornament and then position it at either the left or the right side or the bottom side, and then just add UI also in there. That's a pretty easy thing to do also. So that's pretty nice to add stuff like that in your Vision OS app.
Oh, sorry. Was doing something else. You were saying?
So let's see. I think one of the things that also, so I think it's also great if you already have an iOS or an iPadOS app. Then it also can be launched on Vision OS. You can just start any iPad app. Apple didn't port all the apps yet. For example, the calendar app is just the iPad app right now, and there's not really a Vision OS app yet. They feel a bit intrusive, I would say, because you see that a lot of Vision windows have those glass background and the environment shines through. But iPad apps always have a white background, so they feel really solid, like a little bit of a wall that you place in the room. And they have another problem, like the buttons are often really close together. So Books is also an example where it's just the iPad app. And actually all those buttons on the left side of the view are a little bit too close together. So if you try to focus on them and tap, then often when I actually use that, I have the problem that I tap on the wrong button and I have to try again. What I do myself is often pull the apps really close and then just touch. because it's made for touch. So that's working pretty okay. And you see also the edit button on top is way too close to the edge. That looks really weird. There are good WWDC talks about converting your iPad app to Vision OS and what you can do to add the Vision OS target and support it. So that's something that I would really recommend if you want Vision OS users to use your app, is convert them. You will also be more visible in the Vision OS store, and it doesn't have to be too much work to do that. I think that those already are a lot of stuff that you can do and how Vision OS works. There's a lot more to tell, but I'm also really interested in if there are any specific questions or things that you're interested in that maybe we can zoom into or look at. Are there any questions? Here in the front? Yeah.
Did you already play with hand gesture recognition?
I didn't do that personally. So not in code. In the apps, hand gestures and hand tracking is working pretty well. So what you saw in the WebXR, or those little blocks that were Tom's hands, if you do that yourself, it really feels like your hand. It's pretty good.
But can you get that information, like in a big matrix or array?
Yeah, so you can get that information, but only if you go into an immersive space and push out all the other apps, and you have to ask permission. So the user gets a permission request, like would you allow to allow hand tracking, and then you can do that.
And then you need to make 3D gesture recognizers yourself, probably.
Yeah, you have to do a lot of yourself. But there is sample code out there that can help with things. So if you have ideas, then
can you get any information about your environment, surfaces, walls?
No. Basically, the answer is no.
No.
It's all really closed off. So also the camera feed of the real world, that's also something that's really protected. So that's really hard to. Basically, airplaying like this, what we're doing right now, is nearly the only way to get that feed. Also, getting info, so doing augmented reality yourself, other than hand tracking, is really hard. You can get a service, so you can just ask the Vision, just get me a service so I can place something on it. And then it gets you a service, but you don't know where the service is, what it is, only that it's horizontal or vertical. That's it. If you go into immersive mode again and take over the whole environment and ask for permission, then you can get some more information, but it's really limited right now. And I feel that's one of the bigger limiting factors, because I think there are a lot of cool augmented reality ideas that we could all implement, but it's just not possible right now. I hope they will open up over time.
Hi, thank you for the demo. I was wondering, what are the accessibility learnings using this device?
Yeah, that's an interesting question. I think, so is there a specific thing that you're thinking about?
No, not something specific, but I was just wondering, like, how does accessibility work in real life?
Yeah, so there are quite some accessibility features. I didn't try them a lot myself. We worked together with someone who's blind, and he told me that it's working for him pretty okay. So they did a lot of stuff, but then again, I think one of the things I appreciate most is like the 3D stuff, for example, that you just can't see. So it's a lot of visual stuff. So if you have a visual disability, then I think it's really hard to get the best out of the device at this point in time. They also did a lot of stuff like if you can't use both of your hands, for example, Apple compensated for that. And stuff like VoiceOver, for example, is like other apps. You implement it the same way as other apps. More
questions?
Can you run UI tests?
your UI test? That's a great question. I didn't try. So I don't know. But I assume you can. I assume you can do stuff like that in the simulator also. So I think so, but I don't know. I have to say, as an indie, I don't write a lot of tests.
How do you make a UI test?
You didn't tick the box add test.
Oh, is that a box? I don't know. Never write tests.
Hi. I saw your panorama photos. Did you buy a 360-degree camera already to play around with for your immersive space?
No, didn't buy a 360 camera yet. But I did shoot some videos with the Vision. And those, if you stay still, I think that's the condition, because if you stay still, then that video looks pretty great. Then you really have a feeling of depth, for example. Stuff like that is really working well. Apple also created some immersive videos. Those are in the Apple TV app. Those are also pretty cool. There's, for example, a video of a rhino farm with someone caring for the rhinos, and then they walk up really close, and you really feel like, okay, I have to take a step back because this is not going okay. So I think it's not only the 360 part, but it's also shooting 2 pictures for each eye one. That's really enhancing the experience.
One more question. Do you think Vision OS is built upon iOS or more macOS? Because you have all these multiple things, or iPad OS? Because for your typos app on the Mac, you can inject your keys in the event stream. Can you not do that?
It's definitely iOS.
Yeah, so you cannot do it.
And it's behaving. So if you look at the little details or plug it into, if you have a developer strap into your Mac, and you see what it does, and you analyze a little bit, what is it doing? That's exactly an iOS device.
Okay. Thanks.
Final question.
Do you use it the full day, and like on a full working day, and do you feel more tired on the end of the day when you use it?
Yes and yes. So yeah, I think it's absolutely more tiring. I think so. I did use it a lot because we also created split screen to create an extra virtual display, and I really wanted to test that. So then I take a full day and do my whole work day inside Vision. You really feel the device pushing on your head after, like, I really get annoying feelings after 6 hours or so. So it's it's pretty long, but it's still, well, if you want to do the whole workday, it's not long enough. And I think it's really tiring, especially because my eyes have to focus harder on text, for example. It's less sharp than than an actual display of your Mac, for example. So after a day in Xcode, I really feel like, okay, I have to focus on that letter to really see it well. And I think that's also a hardware limitation. They really have to push still more pixels in those displays to have enough pixels per degree that everything looks sharp. Because it's a 4K display right in front of your eye, but if you then have a 4K display over there, then it still has to share pixels. So that's hard.
Thank you. It was an interesting demo of the Vision OS. Probably more people have more questions, but I think it's best to do that
with a
after
little bit
the
of a
talk,
beer,
so that we can have some drinks and some snacks. I think are also there. Thanks for your time, and at the end of the evening, have a safe journey home, everybody.